today, we're going to talk about these things. We're going to talk about how data flows through the BioKEM environment, how to use Blanca, which is our computing cluster, how to use SBGrid, which is the software package manager on Blanca that we've been using. And then I'll go through these three specific softwares that you might use a lot. And so the documentation for all of this and what we're going to use today can be found if you go to the BioKEM website. It's under this BioKEM user guide tab. So should be easy enough to find there. And it's got most of the stuff about the computing side of the BioKEM facility. This collecting tab, I haven't filled out much yet. I can talk to Eric and try to fill that out later, but haven't done that one very much. But just in general, how data flows through our system here is that you collect your images on either the Krios or soon to be the Glacios. And then those are stored on either Microscope's local storage, which is a server. And then this server, Eric will use a script to push this over to the BioKEM storage server, which is our kind of like holding area. It's safe. It's somewhat redundant, and it'll just keep your data there for a little while until you get to move it. And data on either the Falcon storage server or this BioKEM storage server gets deleted after a certain period, and so you should take it off before 2 weeks. But with the recent implementation of this push to peta library thing that I'll talk about in a second, that shouldn't really be a problem because you'll just have it in real time anyway. And then from there, you can put the data on either one of your local workstations or like the peta library, where you can then have access to computing resources to actually start processing this data. So just getting into the storage a little bit more on the BioKEM facility kind of area. So we have 3 storage devices at the moment, and we'll add a 4th with the Glacios. The Falcon server itself, so the camera's like direct, like where it's putting the images directly after it takes them off the camera, hold about 70 terabytes. And so that's enough storage to store like a month or two's worth of collections. But those will be automatically deleted after a while. But they'll be on there for a little bit, so there's some kind of redundancy on there. And then immediately, all of these data will get shuttled into the interim storage folder, which if you have a lab setup account on the BioKEM storage server, you can have access to that to that folder where your data is, and it'll sit there until you take it off or it reaches the date to be deleted. And then there's a 3rd storage device that's kind of for external users. At least we've been using it for that. That has another 60 terabytes or so for just holding on to data for them if we need to. We could, if you really can't find a place for your data after 2 weeks, we could potentially store for a little bit, but you'd have to talk to Eric about that, and we could get that done. But really, you should try to take it off within 2 weeks. So how you take it off is there are a few methods to do it. The best method is this push to peta library method. So essentially, I've mounted most of the lab's peta libraries that I have access to on the storage server, and we can just directly push all of your images from the storage server to the peta library in pretty much real time. And this is like immediate, and you don't have to do anything. So it's kind of the best method, and everything's safe and fast.
Was that something you set up when you started watching? Probably.
This is Eric will set, if Eric is transferring your data to this interim folder, he'll also set it up to go to the peta library too. So you don't have to do anything for this. Just tell Eric you want it in the peta library, and he should know that too. Another method you could use is Globus or AWS. And these are really for like external people, because it's kind of an easier way for them to interface with our systems. The last kind of good way to do things is if you don't have a pedal library allocation and you want to just take the data off to one of your workstations, your lab should have an account on the storage server. And so then you can just run like a simple rsync. And there's an example command here where you run it inside of a screen. And so you're just rsyncing data from the storage server down to your workstation, where then you have it. So anyone with an account on the storage server, anyone with a folder on the storage server has an account, and anyone with an account can log in and get their own data, but no one else's data. And the bad way to do things is to use an external hard drive, because they're, you can drop them and then you've lost all your data, or they're non-redundant, or they're slow. There's a whole bunch of reasons not to use them. You could in theory, but in today's world, you probably don't need to. And so I would advise against it.
When you're moving data around, do you need to worry about deleting where it came from, or since that auto deletes after 2 weeks, you don't need to worry about that?
No, just leave it there. Yeah, it will delete itself after 2 weeks. Cool. And then, okay, so that's how the data is moving around the system. And then how you kind of get your data if it's not just automatically transferred to you, which hopefully we can get everyone to do that because it's easy and the best way to do it. So then once you have your data, we have access to a couple different cluster computing clusters here at CU, either Blanca or Alpine. And so on Blanca, we've bought into this computing cluster, and so we own. The way this works is if you buy a node, then you get access to the cluster. And so we bought 3 nodes as a group. And so we have access to that. And in theory, we should probably buy some more eventually, but I guess we haven't gotten there yet. And then Alpine is the like CU at large computing cluster that everyone on campus has access to, and other campuses also have access to it as well, because it's part of the Rocky Mountain Accelerated Computing Cluster, I think. So it's got really fast, it's brand new, it opened up last year. It's really fast and has a lot of resources, but because so many other people can use it, you could kind of have to wait for resources, but it's not a bad place to do things. But you'll see there are some limitations with it as well. Yeah, and then we also have this other access to this other service called Cumulus, which is a cloud computing service that CU runs. You probably won't interact with that at all, but just so you know, CryoSPARC is running on that to launch jobs into the cluster, but it's not really relevant for how you use it, but that's where it's happening. Okay, so how do we use these computing clusters, and specifically Blanca? So if you click on this link, we've got a whole menu of things that we can do. And if you just go through them in order, you should be able to log on to Blanca. And so the first thing you need to do is set up an account with research computing. And so you can click this link here and it'll just request an account for you. And anyone at CU can do that. To really use Blanca or Alpine for that matter, you'd need somewhere to put your data when you actually do it. And so each lab should hopefully have one of these pedal library allocations. And so the Luger lab has one, a bunch of other labs to have them. And I would recommend starting out with like 20 terabytes per active project that you want to do things with. And if you're going to be a really active EM lab, maybe 100 or 150 terabytes would be a good place to start. It's pretty cheap. It's very safe. Yeah. So, and if you need to set that up, you can contact Research Computing, and that's currently like $50 a year per terabyte, which is a pretty good price for them doing everything and making sure it's redundant and safe and everything. Another thing to know is that in these pedal library allocations, they actually back up your data at specific increments, and you can go back if you deleted something on accident. for a little bit at least and recover it. Although it's not forever. I think the longest they do is like 2 weeks or something. So if you do delete something, try to find it quickly. Yeah. Cool. And then in theory, each lab.
You say that the loser lab has an allocation there, so.
Yep.
So we can get our username and password from you.
No. So for you'll get your own username, and then that username is but part of a group, and this group can see now this folder. Yeah. But
when I signed up for my research computing account, I in theory can see the loser lab folder.
Yeah, if you were added to our group, which hopefully you would have been, but I don't remember exactly how that works. And then in theory, each lab should also have an SBGrid license if they're going to use SBGrid. This is a little not super well enforced, but most of the labs have them, I think, anyway. So it's pretty good. And then if you want to know more, there's like a bunch of CU trainings and stuff. These are 2 like good ones, supercomputing spin-ups, which can be helpful for figuring out how this all works. I'll give you a brief introduction as to how it works, but this might be a little more in depth. Cool. And then if you go to the next page, we can actually try to log on to Blanca. So if you have an account, you can click this link and it'll take you to Research Computing's Open on Demand web interface, which is their remote desktop app. So if you want to log on to like a workstation, or if you've logged on to other clusters in the past, you'll sometimes do that through a terminal. There are a number of reasons why doing this is better. One is that you don't need to have a Mac or a Linux computer to do it. You could do it on Windows or Chromebook. You can even do it on your phone if you really want to, but it doesn't work very well. But you can do that. So this is the way I'm telling people to get onto the cluster. And it's kind of the best way to do it for a number of reasons. And so when you're on this page, how you actually get onto the cluster is click this little cards, my interactive sessions tab. And then you can see like past ones that you've opened up or current ones that are up. But if you want to launch a new one, you can just click this core desktop tab. And then it'll bring you to this page that asks you for your account, number of hours and number of cores that you want to launch a session for. So the account you can just leave blank. The number of hours, I think the maximum you can put is 24. And so I usually just do 24. You could do less if you wanted. And unless you're going to do some, and so usually you're just using this as a way to get into the cluster. And so you just need 1 core most of the time. That can change in specific instances, but most of the time you just need 1 core. So that should pretty much be what you do every time. It's what I do every time. And then you can press launch. And so now it'll tell you that this job is about ready to start. It's sitting in the queue waiting for those resources to open up. And this will take, a few seconds. And now the card has turned green. So now it's open and ready to go. And you could mess with these sliders. I don't think they really do much. I've never tried to mess with them, but whatever. And then you can just click launch core desktop. So now you're on a remote desktop on the cluster. And to open a terminal to actually start doing things, you can click this black terminal icon up here on the top. And yours might be not in dark mode. I think mine's set to be dark mode here. If yours is not, that's just the default. And so now you're on the cluster in a terminal. And so what you'll see is that your username is here, and then you're on this viz2 in this case. There are 2 viz nodes, so visualization nodes. And these are just for kind of doing some like looking at structures or pulling stuff up. But this is where we're gonna always interface with the cluster here. And so if we go back to our logging on, we've done most of these things. And now we've gotten to our remote desktop. And And so the next thing we need to do is configure our environment. So if you click next, or you click that link, it'll bring you to this page. And really the only thing you need to know here is kind of just copy this command. So I've done this already, and so I want to actually execute it, but you'll need to, the very first time you log on, and only the first time you'll need to log on, you'll need to run this command, and it's just to edit your startup script so that you now have access to all of the things I've put in place to make things work. So it's just going to edit the startup script, and then you won't ever need to deal with it again. So to copy it into this remote desktop, you need to use this slide thing, because this is like technically a different computer kind of. So your clipboard doesn't pass through to the new computer. But to get it to pass through, if you click on this tab and then click on the clipboard, you can paste your, oops, a lot of spaces in there. Paste your command in there. And now that it's in there, you can close that tab, and then click paste in there. And now it's in there. And so I guess I did run it, but essentially all you're doing is putting this line right here into your bash RC file. And this is just an environmental file that I have put a bunch of things in to make things work. And to get this to take effect, all you have to do is just close your terminal and then open the new terminal again. And so now in the future, you won't need to do that step. It'll just happen automatically. Okay. And so now from this, you have access to a few different commands. There's some here, but we can go into all of them in here. So you've got a few different commands in here. The most kind of important one to run right now is one of these interactive commands. These actually get you onto either Alpine or Blanca. And so to get onto one of those, you can type BioKEM-interactive. And this will spawn a 1 CPU interactive job on Blanca that you can then use to run run jobs. And so you can either use the BioKEM one, which will put it on one of our specific nodes, or you can use Blanca-interactive, and it'll just put it on any node at all. So if you run that, you should get a prompt for password, enter your password, and then you'll have to use the dual push to get in. So on your phone, you should have the dual push. If I put it in right, oh, I didn't put my password in. And then you can just press the green accept, and then it should let you in. And so now it's going to take a second to allocate that CPU. And once it does, you'll see a new line now that you're in the actual node. And so this will tell you which node you're specifically on. So now we're on BioKEM 1, which is just one of our nodes. And now from here, you can do a bunch of, you can actually start computing.
You got batch error, batch job submission failed, invalid account.
Yeah. So if your account hasn't been set up to use the BioKEM, or so in order to use Blanca, you need to be given permission to use Blanca. So I just need to give you permission now. And so that will need to be for any new accounts. You need to just tell me that you need permission, and then I'll tell them to give you permission, and then you get permission. But what you should be able to do instead is run Alpine Interactive. Oops, maybe not. No, never mind. Don't run that. I need to fix that one. Cool. Anyway, so now we're back on an interactive job on the Blanca cluster. So what do we have here? Okay, so that's how you get onto Blanca. And there are, let's go here. So there are two ways to run jobs on Blanca if you have your software somewhere where you can find it. And the first way is to run jobs interactively. So that would just be like, just if you're using a workstation, you just call up the job and run it in this terminal here. When you do that, you need to keep the terminal alive, but the terminal can only live for 24 hours because that's all that you can allow it to be alive for. So that's kind of a limitation. The other way to run things is through, an SBatch script. So these clusters are managed by a thing called Slurm, which essentially you give it a file with one of these special headers that look like this, which have all these SBatch directives. And so what you're doing here is telling the cluster, I need these specific resources for this amount of time, and a few other things. And then it will figure out where you should actually be doing the computing, and it will run your job for you, detached from this terminal or anything. So you just submit that job, and it will run when the Slurm scheduler, which is just a computer program, deems that it's a good time for it to run, and it's fair with all of the other users, and then it will run in the background. And if you set it up correctly, you can get a notification when it's done, or you can just check back every once in a while and see if it's done. And if you want to learn more about these SBatch directives, you can probably take one of those supercomputing spin-up classes. But just briefly, you kind of need these general things in each SBatch command, and I've got kind of what they are here. But essentially, you need to tell it where you want it to go, so which partition. The QoS is just a quality of service, and so you can either have it be hours, which is Blanca BioKEM, or preemptible, which allows you to run it on any of the Blanca nodes. But it could get preempted if one of the owner of those nodes wants to use it, but it'll just get requeued elsewhere. So it's not a big deal, and I usually run things preemptively. And then your account is always your account. Then it'll give you a name of job. You'll tell it to use a number of nodes, and so a node is a physical server box, right? And generally, you want that to just be one. There are special cases where you might use more, but generally it's just one. And then you could request GPUs if you want, or different amounts of CPUs, and then a certain amount of memory. And if it exceeds this memory limit, the job will fail. So it's important to know how much memory your jobs are going to run. You can always run like a job at first and see if it fails, and then give it some more memory if you need to. And then there's the time limit. So for things that we have priority on, so if you're submitting through Blanca BioKEM, you can submit up to 7 days. If it's preemptible or on specific lanes on Alpine, you'll just want to use 24 hours. And then these last two here are paths to the output file that you'll be getting, or the error file. And so this is not the actual like data that's coming out of any specific job. It's just anything that would be written to the command line comes in those output or error files. And then you put your the code that you want to execute in the bottom here. And if you want to use one of Research Computing's install programs, you can always use this module load. And if you want to learn more about that, you can take one of those courses. But essentially, if you type module avail, it'll show you all of the different software that is available to you, either through CURC or if you have like custom scripts and stuff. Like I have a few custom modules, but usually you'll just get ones from CURC. And so if you just call module load, and then for instance, we could load an R package, it'll load up that module. And then to figure out which modules you have, you can type module list, and it'll say you've got that R and some other default ones. And then to get rid of it, you can say module unload, or you could also use module purge if you wanted to get rid of all modules. But most of what we'll be doing won't use this. To type of system, but just know that there are software packages installed on CURC using this method. And they're only available on computing nodes. So you have to be on an interactive job or submit an SBatch script to use them. They will also install stuff for you. So if we don't have it installed in like the SBGrid or something, they'll install stuff for you and then make it a module like this for you. So pretty nice. But we probably won't be using much of that. But so that's SBatch scripts. And so programs like RELION or CryoSPARC will actually submit these SBatch scripts for you so that you don't have to mess with them. You'll just kind of tell them what kind of resources you want in the GUI, and it'll submit them for you and just run without you having to figure out how all of this works. So usually you won't have to figure out how this works unless you really want to go in depth. Cool. So a couple other things in the BioKEM environment. So one of the, I guess there are a few other commands here that once you are in this environment, you've used that command to change your environment to this, you'll be given access to a few different aliases and then a few different executables. And so the most important one is probably this SBGrid, which launches the SBGrid software environment. We'll get to that in a second. Another one you can use is Scratch, which will just get you to your Scratch directory. Scratch directory is a storage device that's really fast, and it's good for like, if you want to run jobs there, you can, but it's not backed up. And so it can, if it fails, your data is gone. And it's also not snapshotted ever. So if you delete something, it's gone. I usually just run things in the pedal library allocation because it's super fast anyway. So you're not really limiting yourself there, and then your data is safe and in a place where you logically have it anyway. This S command is just one that I like and I've used for myself. It just shows you which jobs you're running on whatever cluster you're on. So if you're on the Blanca cluster, it'll show you which jobs you're running. So like if I say S, I'm just running these two interactive jobs on Blanca BioKEM. That command is actually this, which is kind of a pain to write out. And so that's why I just made it S every time, because this is a command you use a lot, but it's a lot easier to just type S. So, and this will be whatever your username is. So it's already set up to be your username. Cool. And then the last one is just kind of a custom one that I think is a little interesting. If you want to see what kind of GPUs are currently installed on the Blanca cluster at the moment, you can type that Blanca GPUs command, and it'll just show you what kind of GPUs we're dealing with. If you know more about how that command works, you can get different information from this, but it's a little technical. But this is kind of the relevant one, I think, anyway. Cool. So after that, we talked about this this BioKEM command, this BioKEM interactive command, but there's actually another way to use it. So if we just back out here, so we're back on the Viz node again, so we're not on a BioKEM or a Blanca cluster anymore, but we can use this command now. If we want to run jobs interactively, we can use it to request specific amounts of resources. So if you just run it without any flags, it just allocates one CPU. So you wouldn't actually do any computing on it, but you could use it to launch a GUI that would then submit jobs for you. But if you want to do interactive computing, you can give it the number of CPUs using C. So if I wanted 16 CPUs and a GPU and then a certain amount of memory, you could give it a command like this. One of the detractions of doing an interactive job like this is that, so now I've requested a lot of resources, and before this interactive job will start. So I can't even set up my job. I have to wait for those resources to become available. Versus if you submit an SBATch script, it'll just submit it and run it whenever it gets a chance to. But now you can't even set the job up because you have to wait for it. Although when you run it with priority, like I just did, you can get that quickly. So it's a mixed bag. The other thing is, again, you only have 24 hours. So if your job's going to take more than 24 hours, this doesn't really work to do it like this. But it's an option. You can also use the Blanca interactive in the same way. So this one will probably take longer to queue. Just because now we're competing with everyone without priority now. But the thing is, there are more resources when you do it this way. So you kind of have to try those out and figure out if it makes sense or not. Oops. Let's start over here. Okay. And I did have this passwordless a while ago, but they changed their security. So now you have to enter your password every time. But not that big of a deal. Okay. And then I'll talk about these two other commands, and then we can talk about specific use cases here. So the two other commands that you'll have access to are this slurm error. So what's going on in the background is that for most of the SBATch scripts that I've templated for you, like in CryoSPARC, RELION, or AlphaFold, it'll write to a specific directory in your home directory, which you can go into and look at any of the jobs whenever you want. But an easier way to do it is just run this like slurm error or slurm out command, and it'll just grab the most recent job you've submitted from that. And so like there was no output from that job. But the other thing you can do is give this, if you know what the ID of the job that you ran is, you can just give it that job ID, and then it'll look up that one for you. The other way to do this is just actually read the specific file in your home directory. So if you went to this, thing with this is that, you know, if you've run a bunch of jobs, you have a bunch of things, and it's hard to figure out which one's which and stuff. So it's nice to just have the quick and easy one there. And you can figure out what the job ID is, sometimes through the interactive GUI. And if not, then you can use that S command again to look at the job ID of currently running jobs here. So that's that. Yeah. And so then I think the other thing, so the big way we're going to run software on the cluster is through SBGrid. And so to open up the SBGrid environment, all you need to do is be on an interactive job. So we're on an interactive job, and then type SBGrid. And so here you'll get the SBGrid like welcome message, which, you know, tells you how to cite it and like, you know, tells you all these things. And then the other thing you'll notice is it gives you these like configurations that are either personal or that you've or that have been set up by your administrator, which would be me in this case. And so I've set up one site-wide configuration. So this is just to use a specific version of iMod that's not the default. And then I've also set a specific version of eman2 that I want to use up in my personal one. And if you want to do this, I think I have documentation on how to do this. Maybe not. But essentially, if you want to change for some reason which SBGrid package is your default, you can look in your home directory. Ooh, and you should have a file called SBGrid somewhere. Yeah. So you should have a file called sbgrid.conf. And if you look in there, you can edit that file and set it up like this to to use specific packages in your SBGrid install. You can also do this just each time you start up SBGrid. So if you want to use a different specific package every time of eman2, you can just run this as an argument. So if I say, oh, I don't know what. So if you want to check which ones are available, you can type SBGrid -info -L, and then the name of the program you want to know about. And so it'll tell you that the default version is 2.99, but I'm using this other version. And if I wanted to change the version I'm using, I can just use this variable. And so to set this variable, you can just go eman2_x. The X is for Linux. And then copy the version you want to use, execute that command. And now when I rerun this command asking for info about it, it'll say I'm now using the new version. So that's one of the ways you can check out all of the versions of a program that SBGrid has installed. And so there's one SBGrid install for all of us that's set up through that source file again. And I just update it pretty frequently. I think I might set it up to do an auto update, although that's kind of hard on the cluster just because nothing persists for very long. But essentially you have it's probably like 1,000 different programs or something that you have access to, and you can go to their website to learn more about each of the programs that are installed. And then you can use this command to try to look at which specific ones you want to install or that you want to use at a specific time. And I've set it up to be install almost all versions that they have available. So if there's a previous version that you really like, it's probably installed unless there's something like super wrong with it. But yeah, and so to run any of these specific programs, you can just navigate to wherever you're going to run it. So in this case, I would go to our meta library allocation, and see if I remember what I did. Yeah, so you can go to your meta library allocation, and then if you want to if you know the executable that you're trying to run, you can just type the name of the executable. So in this case, to run eman2, the executable is e2 project manager.py. And so then it just starts up. And so essentially all the executables that SBGrid has available to it are already in your path once you load the SBGrid environment. So you can run, and this GUI takes a while to start, but it'll start eventually. But yeah, so that's how you use just general SBGrid software. I have a couple other specific examples that we can go through. Let's just start a new one here. And the first one is AlphaFold, which I think a lot of people are trying to use these days. We have an AlphaFold installed through SBGrid. You could install this yourself. The reason you're probably better off using my install is that you have to download like a 2.5 terabyte database in order to run it. And so I've got this installed in a place where everyone can use it, but you won't have to do anything to actually use it. So, and I've also wrapped it a bunch so you don't have to like do all of the interactive stuff that you might have to otherwise. So we can go to this and to launch an AlphaFold job, it's pretty darn simple. I've written this executable called AlphaFold predict, and all you have to do is give it your FASTA file and click enter. And so it'll give you a little information about what it thinks you want from it. So you've got the FASTA file in the correct format. It's detecting only a single caret, which is the FASTA way to denote a new protein. And then it's going to figure out how many total residues there are, and then figure out which script it should use to submit that. And so in this case, you're just submitting this. It's just a monomer. And so it figured out that it was a monomer, and it's a small monomer. So it's just going to submit enough resources essentially to fold what it thinks would be a small monomer. You can also predict multimers. So if you just predict a file with a multimer in it, now it'll read that there are more than one of those carets, and it'll select to submit this as using different resources and different code to run the multimer version. So it's pretty easy, and it works pretty well. If you need to know what,
File, there's no difference.
no, it's just going to look through the file, make sure that you have more than one caret, and then submit it as a multimer. And so if you look at those FASTA files, all you need in a FASTA file is a caret and the name of your protein, and then the sequence on the next line. And that's all you need in the FASTA file. But you do have to have the caret, and then the next line has to be the sequence. And if you want to do a multimer, oops. It's similar. You just have your name of your first protein, the sequence for it. And in this case, I'm folding a homodimer. And so it's the same thing back here, but essentially you just put it right next to it, or put it right underneath it, the new entry. And that's all you need to do to submit it. And you can put, octamers or whatever. You can just, as long as you just keep adding entries in this format, it'll submit it as a multimer. So it's pretty simple. And you can see that that's running, or at least waiting in the queue to run in these different, with this name AlphaFold now. So that's an
What does resources versus priority mean?
So resources means you're next in line if the resources that you request become available. So for this specific job, you're going to request a GPU, which are there's only so many of them on the cluster, and they're sometimes in high demand. And so that's probably your limiting factor here. And so it's waiting for a GPU that you've asked for to become available. And then if it says priority, it means you're not the next one on the list, but you're down somewhere on the list. So once other people's jobs start, then yours will be put in that position to get resources. And generally, these can sit in there for a while. They can sit in there for a really long time if the cluster is being used greedy by everyone. But normally they won't sit in there very long because there are a lot of resources. And the way I'm submitting these is to the cluster at large, so not with priority. But because of that, there are a lot more GPUs available for them to run. And so you could submit a bunch of them. Like I had my undergrad submit like 400 of them the other day, and each of them required a GPU, or more than one GPU, but they all ran within a couple days. So they'll just sit in the queue until they run. And you can just check on the status here if you want. And to the output of AlphaFold just is put into the error file. I'm not really sure why it's put into the error file, but if it was the only job you've submitted, then you can just click slurm error. But in this case, the file hasn't been created because the job hasn't run yet. But if you want to just check on each of these jobs, you can look in the error file, just like we did before. So yeah, and then the other thing that this script will output is this .q file, which is the actual SBatch submission script that it's submitting. And the reason I let it do this is sometimes it won't request enough resources, and so your AlphaFold job it'll never make it to the end. It'll never actually finish. And so you can go in here, and if you know what you're doing, you can edit some of these SBatch directives to give it more resources or something. And then resubmit it using just, you can submit an SBatch job by just using the SBatch command, and then giving it the file, the SBatch file as an argument. So just like that. And when you do that, it'll output the job number for you, and now you'll see it in the queue. So, and then just as a point of how AlphaFold works, these are folders that I've already folded. And so if we look in this monomer one, this was a monomer that I told to fold. And so it'll give you a bunch of different files in here. If the job is finished, it will have these files called ranked, and then a number.pdb. That means it's folded all the models, looked at all the models, and figured out which one it thinks is the best answer. And the best answer is always this ranked _0 .pdb file. You can also, there's a couple, if you look in it further, there's a couple ways to look at some metrics of which ones it thinks are best. So if you look at the rankings debugged JSON, it'll give you for each of these models it folded, it'll give you a score, and the highest score is the best model that I picked. So, but you can look at the other PDBs as well, just to see what happened. The way I've set it up, it's only going to fold 5 models, and that was just to get really big structures to the finish, because each of the structures takes a long time to fold. If you want to change that, you can change that in the SBatch script when you submit it. And you can change it to whatever you want, I guess, but 5 seems to be pretty good. And then when you look at the multimer output, you will get a similar thing, except now it makes, I think it makes 5 models of each of them and then like crosses them in every way. So this is the real advantage of doing less models, is that now you need to fold a whole bunch of different models at once. So, but it gives you the same kind of information. Ranked 0 is the best one, and then you can look at the metrics in the timings. And then the other thing to note with this is that it only does an amber minimization on the best model. So if you want it to be minimized, you'll need to minimize it yourself after that point. Okay, so that's how you use AlphaFold. The 2 other programs we can look at are RELION and CryoSPARC. And so we can look at RELION first. And so to start RELION, you just need to be an interactive job. And I think there's some documentation for this. So you just need to start an interactive job. You need to navigate to where you want to do the computing. And then you start the SBGrid. And then you just type RELION. So it's pretty simple. And I can't remember if we've started SBGrid, but it'll give me an error. Okay. And then you just type RELION. And just like normal, it'll ask you if this is actually a new project directory. And so you can say yes, and then it brings you to the RELION GUI. And so this is just like normal. The only difference is that when you submit a job, so you go to this running tab, normally if you're just running it on your own workstation, you'll leave this as a no. But in this case, you do want to submit it to a queue because that's the whole reason we have the cluster. So you'll say yes, and then it should be automatically populated with all of these variables that are going to make the SBatch script it will eventually submit. And you can change these in specific ways. You can look at the documentation to figure out how to do that. Probably the only thing that you really need to concern yourself with is the amount of memory you give it, and the number of GPUs, and maybe the wall clock once in a while too. But other than that, you can just click run from here, and it'll submit it as an SBatch script without you having to fill out the SBatch script. So that's a nice way to do that. The other thing you can do with RELION that I haven't experimented much with is you can do the on-the-fly data processing that you could do in like CryoSPARC Live. You can do that with RELION. It's a little more complicated, and they have a documentation page that'll show you how to do that. But I would probably just use CryoSPARC Live most of the time. So, but yeah, so that's RELION. And then the last one I want to talk about is CryoSPARC, which is probably the use case for most people, besides maybe AlphaFold. And so CryoSPARC is difficult to set up. And so I've set it up for everyone specifically that has a petal library and has asked me to do so. So if you want to use CryoSPARC on the cluster, you need a petal library, and then you need to tell me that you want me to set you up one, because they're fairly complicated to set up. But on your end, all you need to do is start a new terminal. And in this time, you want to be on the viz node. You don't want to use an interactive job or anything. You're just on the viz node. And then you should just be able to type CryoSPARC if everything's configured properly, if I've done everything right, and then it will launch a Firefox browser window and take you to the right location for your CryoSPARC. So this is ours. This is the Luger Labs. And I guess here, the couple of things I want to show you about are like if we went into one of these, when you go to build a job, just like normal, oops. So we'll just build a Topaz trained up, I guess. Sorry, let's just use motion correction as an example. So for building this job, you give it the normal inputs that you normally would and everything. And then when you go to, and you can give it the whatever number of GPUs you want. Usually, just as a side note, on Alpine, I think the nodes usually only have 3 GPUs at most, but they're all 8100s, so they're really fast. On Blanca, they have up to 4 GPUs, but I tend to use just 3 because if you try to use 4, then you'll have to request kind of the whole node as a thing. So I usually, if I'm doing like motion correction, will just request 3 on whatever I'm doing, but you can request 1 or 2 or 3 or whatever. So when you go to this Q job, the difference here now between CryoSPARC you might have run on your workstation and on the cluster is that you now have these Q lanes. So there are a couple different Q lanes. The first one is Alpine. So you can submit a job as long as it doesn't rely on SBGrid software like Topaz. You can submit it to Alpine. And so this is a good place to do a lot of computing if you want to do a lot of computing. Got a lot of fast QPUs over there. The other one is you can submit it to Blanca at large. It should run just fine. You could submit it with priority to Blanca BioKEM if you want. If a bunch of people do this, then you'll have to wait in line because now we're all using the limited resources that we have. But you can submit it there. This lane might not appear in everyone's. I don't think we really need it, but if you have it, it will essentially let you use one of the BioKEM nodes, but it'll give you way more resources than normal. And it will only, it'll only submit it to one of the nodes, which has a large SSD. So if you wanted to do some SSD computing, you have to use this node. All of the other nodes everywhere are configured to use the SSD for particle caching or whatever, but the specific size of each of those SSDs is different depending on which node you're on. And a lot of them are pretty small, so it probably won't work very well unless you use this one, and even then it might not be big enough to cache all your particles. So usually I would just turn SSD caching off, but if you want to use it, you can try it here. If it doesn't work, just turn it off and go without it. And then the last one is the way CryoSPARC submits jobs is that it has a theoretical memory that it's supposed to do for each job type. And sometimes it's just not enough. And so this job will submit a job to Blanca, but it'll always give 128 gigs of memory, which is generally plenty of memory for whatever job you're running. So if you run into memory issues, try running it on this lane and see what happens. The drawback again is that some nodes only have like this much memory or just a little bit more, and so you'll have to wait in line to use those nodes. But some of them have like 512 gigs of memory, so it's not a problem. Cool. And then you just press Q. And so I guess if we queued this, let's queue with some priority so we can see it run. So now it, oops, what happened?
So this is the problem that I'm running into, Sean. What you're seeing right here is when yeah, it doesn't do anything. And I can't get past it. It's,
Well, yeah, okay.
it's gonna lag for like 20 minutes and then it'll go.
Okay, that might just be a, yeah, I'm not really sure what that is, but I think if I restart this a few times, it might behave. But essentially, you queue it, and then when you do, you'll get this show from top. You'll get this dialog that's showing you the actual SBatch submission script that it submitted, the command it's actually doing. And then you can monitor your job right here. So instead of running that SQ command, and in this case, it's actually submitting it as the BioKEM user and not your user. So that's just a thing to remember. But it'll run that command for you and show you how your job's doing. And then it'll show you everything that's going on. And then it's just like CryoSPARC like normal. The one caveat to that is that when you run a Topaz job or a job that runs on non-CryoSPARC software. So if I cloned this, oops, one of these arguments is path to executable. I have the path to this executable that you'll need in the documentation here. So you just copy this over and put that in there. And you can actually set that for your entire workspace, I think, so you don't have to do it every time if you're doing a lot of Topaz train jobs or something. So that's the only really caveat you need to do. And then if you're going to do like a Topaz job, it has to be on one of the Blanca clusters because it uses SBGrid, which is only available on the Blanca cluster. So you'll get an error if you try to do it on Alpine. But that's that. And then the one other thing that you can do on CryoSPARC is run a CryoSPARC live session. So it's because you can get data in real time now from the microscope, you can just set up a CryoSPARC live session to start pre-processing your stuff as it's coming in, and you can kind of tweak things as it's going along. This kind of takes a while to set up, but essentially I've got a whole bunch of parameters here that you should follow when you start a CryoSPARC live job. And if you do this, it's pretty intuitive and you can just watch your particles as they come in. Yeah. And I think that's all I have to say about CryoSPARC. If you want a newer version or to update it, I'll try to update them as new versions come out, but I have to do that. Users can't do that. And if you're used to running like the CryoSPARC M commands, you won't be able to do that either. I'm trying to get away where you can use the restart command and only the restart command, but I'm running into some problems with it, but you might be able to do that in the future. But, yeah. So other than that, I think that's all I have for this. You guys have any questions? Okay.
I have a few questions I can ask you later.
I mean, if you have general questions.
This one, so when you just typed in CryoSPARC,
Mhm.
I know I think that they have the same problem that I have, that it pulls up the window about the restart Firefox. So the workaround you gave me does work.
Mhm.
restart for Firefox and put in the alias.
Mhm.
That's the only way I can get in now. Is that okay? Or
It's okay. It's not ideal. They're working on a fix for it, but if you do run into like a Firefox issue with CryoSPARC, yeah, use these tips to try to get around it. If it still doesn't work, that's
I can
then
get
send
in,
me
it's
an
just
email.
every time I have to open the new for desktop, I have to do this again. And so I'm just wondering, that's fine, though. I'm not like doing anything wrong.
If you can get in, it's fine, yeah, but it's annoying that it doesn't work quite as well as it should, but.
Well, it didn't happen to me for a really long time, but then since it happened, I can only get it this way.
And it never happens to me, so I don't know what the difference is, but we'll try to fix that though.
We should fix it, but, there's like some Firefox file that creates a new that we can get it.
Okay.
I can show you.
Yeah. Cool. Okay, cool. Well, let me know if you have any questions. Email me and I'll try to fix them.